Airbus has submitted the A380 wing design. We looked at innovations in terms of the aerodynamic codes, structures, loads, fuel systems, and the integration of all those technologies gave us a result that was far greater than the sum of the parts.
Brinker Technology has a technology that is capable of locating and sealing leaks in pressurised fluid systems, particularly pipelines. The range of those pipelines that the technology can be applied to is very considerable.
This particular innovation is closing the carbon loop. We have taken a bio raw material, ethanol, which is obtained from plants, and converted that into ethyl acetate, which will be released to the atmosphere and biodegrade into CO2.
We've innovated a device that is capable of imaging 85% of the retina in one go, improving the standard of healthcare that eye doctors can offer their patients.
The McRobert Award is a very proud piece of the Academy's activity. It's a hall of fame if you go through the McRobert winners of the past. Both the innovation and the commercial success have always been there. We now want to give it a public image which people will recognize has come from the success of the engineering. This is a genuine reward for the highest level of technology in the field. In the last few years, the two biggest developments have been the way engineering has moved into the bio side and software. We are actually setting out to achieve different and diverse entrants. We achieve this by having groups of finalists each year, which themselves are diverse. But it does lead to some very difficult decisions. This year is no exception. Frankly, any of these four is a potential winner.
The challenge that we were set was to improve by about 20% on what was flying at the moment. The customers said they wanted a larger, more comfortable aircraft, cheaper, more efficient and more environmentally friendly, and also to fit in with the existing airport infrastructure. The wing is the main part of this programme, which is designed and built in the UK. We had to look at every single element of the design process and take it apart and look for innovations right the way throughout. Not only in all individual areas of technology, but the integration of all those different scientific disciplines all together in a huge team-working effort. We looked at using the fuel to balance the aircraft as a ballast so we could move actively through all stages of the flight process. Another big innovation was a big advance in the aerodynamics tools and technology, the computational fluid dynamics techniques, where we did a fully integrated wing and power plant design. It was the first time that that's really been done. The other one I would have to highlight is the knowledge-based engineering technique for actually then linking together all of the technologies from the different areas, structures, mass, flight physics, aerodynamics, loads, to allow us to optimise the performance of the wing. We managed to do many different wing designs, which gave us a real step change in the performance. It involves 400 companies and about 22,000 people in direct employment. We're very confident that what we've designed now is the aeroplane that customers want. They've actually responded by putting an unprecedented number of orders in advance of the sale of the aircraft. Society will gain from responding to the demand for increased air travel in a more environmentally friendly way. Airbus have achieved what we set out to achieve.
Brinker Technology have developed mechanical platelets. A mechanical platelet is a solid object that we inject into the pipeline. Platelets are generally made of different types of polymer, and there's a lot of various clever things we can do to the polymers to give them precisely the properties that we need to meet both the fluid mechanics constraints and also the structural constraints of forming the seal. So there's a huge range of what a platelet might be in terms of size and shape. We can work from very small pipelines used in the oil industry up to 48-inch large overland diameter pipelines. The sheer range of the technology has surprised ourselves as new applications keep arriving.
The critical part of it is actually understanding the dynamics of pipeline flow, what's actually going on in the flow, and what's happening in the leak site. The beauty about this technology, you can remotely inject platelets into a pipeline system, and the platelets will go with the flow, find the leak, and seal it. So there's an immediate cost benefit.
There's a huge opportunity for us to take the technology out to address some of the problems in the water industry. That's significant for the UK, but I think it's also significant globally.
The beginnings of Brinker Technology as a company is as a spin-out from the University of Aberdeen. Our strategy was to engage the end user, basically the oil and gas companies on our doorstep. We're a small company. Brinker Technology needs to stay very focused. Our big challenge for the future is not, I think, introducing the technology into the worldwide market, it's controlling our growth.
We help doctors. We save sight and we save lives. The innovation is principally a unique scanning laser system that's positioned virtually inside the patient's eye. Very low power lasers are shone into the eye and are scanned across the retina, and the reflected light that comes back from the retina is how we create the digital image. The use of ellipsoidal mirror technology gives a huge field of view inside the eye. Without a good light source, we couldn't have innovated our product. Having said that, an awful lot of the rest of the innovation has been driven by Optos. The scanning system itself is very high specification. It's fast, it's efficient, it's highly productive for the eye care professional, it's comfortable for the patient, and what's more, it's very educational for the patient to see an image of their own retina on a computer screen in front of them. The repeatability of being able to image across patients of all creed, colours, races, facial types is just an enormously satisfying event. The challenge was to overcome some existing thinking that what we were trying to do was impossible, and the revelation that this was possible was a huge eureka moment. We've got over 2,000 systems in various markets around the world. Every day our instruments contact us and tell us how many images they've taken, and we track that. To date we've taken over 7 million retinal examinations, and that's growing at a rate of 10,000 per day. In terms of revenue growth, that represents over 60% growth on our previous financial year. At the moment there are over 100 million eye examinations on an annual basis. That's our target market. And we've got a huge roadmap planned ahead of us where we can exploit the digital content of the images and enhance the way that the images are captured and present the doctors with even more information to assist them in their diagnosis and care and treatment plans of patients.
We're changing the source from petrochemicals through to a renewable biological base, but at the same time we're not changing the underlying technology, we're not changing the chemical that we're making, so you only have to do one innovation. As a company we produce process technology licenses for the petrochemicals and fine chemicals industry. We don't make anything per se, but we develop and research new processes.
We make our money through the licensing of the technology. We have to use innovative chemistry, innovative engineering to overcome these new problems.
Innovation is the key. Things have to be different, they have to be better, and that's often cheaper.
The fact that prices of fossil fuels is going up and they are becoming more scarce has opened up the opportunity for using bio-based feedstocks. Also, the technology is improving very rapidly and hence those prices are going down. The potential for using biorenewable fuels is tremendous. However, it's not going to happen overnight. We're also looking at other technologies as well, which will use renewable feedstocks for making products which are currently produced through fossil fuels.
You can make ethyl acetate where you have agriculture, so it can be moved out to where it's required. What David produces is the information to make a full-scale industrial plant. What we start from is an idea. We use mini plants, and these are fairly small scale, but they are exact mimics of a larger scale plant. Well, when you take the information from Davy Process Technology, the next thing you do is you build the plant.
This technology is readily available and can be used by the developing world.
It's really tangible, this sense of impatience, excitement, wishing to shout from the rooftops what they have done. And if ever anyone doubts the fact that engineering is strong and making a huge contribution to the advancement of science and industry in the UK, I'd reach them the brochure of past winners and past finalists of the McRobert Award. We have to say in the end that the one which stands out is the one which has the greatest degree of innovation, proven commercial success, and the most stunning contribution to the community.